At the end of this video lesson, you should be able to explain how earthquake waves provide information about the interior of the Earth.
Earthquakes cannot be predicted. Scientists have tried many different ways of predicting earthquakes, but none of them became successful. On any particular fault visited and inspected, seismologists can say there will be another earthquake sometime in the future, but they have no way of telling when exactly it will happen. Although it is unlikely to predict earthquakes, the areas most at risk can be identified so that necessary precautions should be undertaken by the probable areas to be affected. This includes strictly meeting the infrastructure and building regulations set by the local government so as to withstand earthquake shocks.
This video lesson is a continuation of our discussion about earthquakes and faults. But before we discuss, let us recall some of the terminologies that we have learned last time. The first one is seismology. It is the study of earthquakes and seismic waves that move through and around the Earth. A seismologist is a scientist who studies earthquakes and seismic waves. What are seismic waves? The vibrations are more properly called seismic waves. As seismic waves travel through the body of the Earth, they behave in different ways depending on what they encounter along the way. Seismic waves are the waves of energy caused by the sudden breaking of rock within the Earth or an explosion. They are the energy that travels through the Earth and is recorded on seismographs. Types of seismic waves. The first type of seismic wave is body wave. It is a seismic wave that moves through the interior of the Earth. Earthquake waves emanating from the focus or hypocenter travel in different directions and at different speeds. Of the two major types of seismic waves, the body waves play an important role in providing scientists with information about the nature and composition of the Earth's interior. Up to this modern time, only about 10 kilometers of the Earth's crust have been drilled and mined. Researchers have drilled deep holes, such as the holes in oil wells, into the crust, both in the continents and in the ocean floor, but no hole has ever been drilled all the way through the crust and into the mantle. Miners in various places observe that as the depth increases, temperature and pressure are likewise increasing tremendously. Thus, the high temperature and pressure served as the obstacles for geologists to go further. Consequently, limited information about the nature and composition of the Earth's interior had been gathered directly by geologists. But a lot of information has been said about the Earth's interior. The materials of the Earth's interior vary in density. The outer core is liquid in form, and inner core is composed of dense iron and nickel. Where then does this wealth of information about the Earth's interior come from? All this information about the Earth's interior has come from analyzing the behavior of body waves. Body waves are types of waves traveling through the interior of the Earth. Body waves arrive before the surface waves emitted by an earthquake. These waves are of a higher frequency than surface waves. The first kind of body wave is the P wave or primary wave. Primary wave are the fastest kind of seismic wave and consequently the first to arrive at a seismic station. The P wave can move through solid rock and fluids like water or the liquid layers of the earth. It pushes and pulls the rocks it moves through just like sound waves push and pull the air. P waves are also known as compressional waves because of the pushing and pulling they do. Subjected to a P wave, particles move in the same direction that wave is moving in, which is the direction that the energy is traveling in and is sometimes called the direction of the wave propagation. So this is an animation of the movement of a primary wave, or also known as compressional waves. They pushes and pulls. The particles move in the same direction that wave is moving in, which is in the direction that the energy is traveling in. Next is the second type of wave is the S wave or secondary wave, which is the second wave you feel in an earthquake. An S wave is slower than a P wave and can only move through solid rock, not through any liquid medium. S waves or secondary waves, also called shear waves, travel with a velocity that depends only on the rigidity and density of the material through which they travel. S waves travel through the material by shearing it or changing its shape in the direction perpendicular to the direction of travel. Materials without rigidity cannot be sheared. Secondary waves travel slower than primary waves, so they will reach the seismograph after the P waves. So it is this property of S waves that led seismologists to conclude that the Earth's outer core is a liquid. So S waves move rock particles up and down or side to side, perpendicular to the direction that the wave is traveling in, which is the direction of the wave propagation. This is the animation of the direction of the propagation of secondary waves. Remember that secondary waves are also known as shear waves. They travel with a velocity that depends only on the rigidity and density of the material through which they travel. The second type of wave is the surface wave. So again, the first type is the body wave, then followed by the surface wave. In body waves, we have primary and secondary waves, whereas surface waves are traveling only through the crust. Surface waves are of lower frequency than body waves and are easily distinguished on a seismogram as a result. Though they arrive after body waves, it is surface waves that are almost entirely responsible for the damage and destruction associated with earthquakes. So you will be discussing more of surface waves to detail or into deeper discussion in grade 10. But I'll just give you the two types of surface waves. As seismic waves travel through the interior part of the Earth, they behave in different ways depending on what they encounter along the way. The waves speed up as they travel deeper into the crust, while slow down in the upper part of the mantle where rocks are partially molten. Seismic waves, particularly the S waves, disappear as the waves reach the core. Remember that secondary wave travels only in solid but not in liquid, since the outer core is liquid, S waves or secondary waves disappear as the waves reach the core. The idea that the S waves cannot travel through any liquid medium led seismologists to conclude that the outer core is liquid. Earthquake provide information to seismologists about the interior of the Earth. Earthquake waves and seismic waves are both dangerous, but these waves help us in the development of our understanding on the interior layers of the Earth. Remember that seismic waves travel deeper into the crust, they speed up. That means that at depth, the rocks are denser. In the upper part of the mantle, the waves slow down. That means the rocks there are partially molten. As the waves reach the core, one kind of seismic wave, again that is S waves, disappears. That means that the outer core is liquid. At certain depths, the waves are reflected and refracted or bent. That means the Earth must be layered. P waves and S waves are primary tools scientists use to understand the properties of each layer of the Earth. P waves and S waves travel differently through liquids and solids. We can use the waves from earthquake to understand what the layers of the Earth are and what their mechanical properties are. Now let us proceed with the types of surface waves. The first type of surface wave is called the love wave. The love wave is the fastest surface wave and moves the ground from side to side. It is confined to the surface of the crust. Love waves produce entirely horizontal motion. Named after A.E.H. Love, a British mathematician who worked out the mathematical model for this kind of wave in 1911. So this is the direction of propagation for love wave. They move in horizontal directions or sideways. Next type of surface wave is Rayleigh wave that rolls along the ground just like a wave rolls across a lake or an ocean. Because it rolls, it moves the ground up and down and side to side in the same direction that the wave is moving. Most of the shaking felt from an earthquake is due to the Rayleigh wave, which can be much larger than the other waves. Named for John William Strutt, Lord Rayleigh, who mathematically predicted the existence of this kind of wave in 1885. So this is how a Rayleigh wave moves in rolling motion.
Earthquake waves give us a picture of the Earth's interior. The way an ultrasound provides an image of a baby inside the womb. This is why scientists know a bit of the interior of our home planet, even if no one has gone deep into the Earth yet. We often think of earthquake as something harmful, and the reason is obvious. But earthquakes help scientists to figure out what is inside the Earth. How? As you know by now, when a fault suddenly moves, an earthquake is generated. The shaking starts from the focus and spreads out. You can get an idea of how this happens by throwing a pebble into a pond. See the ripples that move out in circles? The vibrations from the focus are something like that. The vibrations are moved properly by seismic waves.
Let's sum up before we answer some questions. There are two types of seismic waves. Two types of seismic waves are generated during an earthquake. The body waves, consisting of P wave and S waves, and the surface waves. Body waves pass through the Earth's interior and provide a lot of information about its nature and composition. There are two types of surface waves. We have the love wave that moves side to side, while we have Rayleigh wave which moves in rolling motion. Question number 1. It can travel through solids only. A. Primary wave, B. Love wave, C. Secondary wave, D. Rayleigh wave. Time starts now. Number 2. Which type of wave arrived first during an earthquake? A. Primary wave, B. Secondary wave, C. Love wave, D. Rayleigh wave. Three. Main type of wave that can travel the Earth's inner layer. A. Body wave, B. Love wave, C. Surface wave, D. Rayleigh wave. Number 4. This is considered as the fastest kind of seismic wave. A. Love wave, B. Body wave, C. Primary wave, D. Secondary wave. And number 5. Which type of wave is shown? A. Rayleigh wave, B. Love wave, C. Secondary wave, D. Primary wave. Alright, for question number 1, the answer is letter C. Number 2, the answer is letter A. Number 3, it's letter A. Number 4, letter C. And number 5, letter D. So thank you for watching this video lesson. See you again next time.